Have you ever wondered how the properties of materials are altered for specific uses? How does a blacksmith forge a sword that is both hard enough to maintain a sharp edge, yet flexible enough not to shatter upon impact? Or how is glass made to be tough and resistant for use in a skyscraper? The answer lies in the fascinating world of heat treatment. Heat treatment is a collection of industrial, thermal, and metalworking processes used to tweak the physical and sometimes chemical properties of a material. Its most common application is in metallurgy, but it's also employed in the manufacture of other materials, such as glass. Heat treatment involves the use of heating or chilling, typically to extreme temperatures, to achieve a specific result. This could be hardening or softening of a material, depending on the desired outcome. Now, there are several key types of heat treatments, each with its own unique process and purpose. Firstly, there's annealing. This involves heating a material, usually metal, to a specified temperature and then cooling it at a very slow rate. The magic of annealing lies in its ability to reduce hardness, improve ductility, and relieve internal stresses. A material that's been annealed is more workable and less likely to crack under pressure. Next up, we have quenching. This is a process that involves heating a metal to a high temperature and then rapidly cooling it in water, oil, or air. The result? An increase in the hardness and strength of the metal. Quenching is a bit like a high-intensity workout for the metal, making it stronger and more resilient. However, just like a bodybuilder needs to stretch after a heavy workout, metal too needs to undergo a process called tempering after quenching. Tempering involves heating the metal to a temperature below its critical point for a certain period of time, then cooling it in air. This process is used to eliminate the brittleness of quenched steel while maintaining the hardness and strength imparted by the quenching. So, in essence, tempering gives the metal a perfect balance of strength and flexibility. Then there's normalizing. This process involves heating the metal above its recrystallization temperature and then air cooling it outside the furnace. Normalizing refines the grain structure and improves the mechanical properties of the metal, such as toughness and strength. It's a sort of reset button, returning the metal to its natural state, but with improved properties. Finally, we have case hardening. This is a process that combines aspects of hardening and tempering, aimed at creating a hard wear-resistant surface layer or case on the metal, while maintaining a tougher and more ductile interior. Methods include carburizing, nitriding, and carbonitriding. Case hardening is like giving the metal a tough outer shell while keeping its core resilient and malleable. Each of these processes affects the microstructure of the material in different ways, leading to changes in its properties. The specific process chosen depends on the desired characteristics of the material and its intended use. In conclusion, heat treatment is a fascinating and vital process in the world of material science. It's through these processes that we can alter the properties of materials to suit specific uses, from the creation of a durable glass skyscraper to the forging of a resilient steel sword. Heat treatment truly is the unsung hero of industrial and manufacturing processes.